Jigs and fixtures are used in delicate parts. Their general purpose is to locate and hold the work securely. The cover, if we rest it on a single point, it can still move in a number of ways. It can rock up on 2 points and one of these tilting movements is accomplished, but if a movement. A 5th point restricts the freedom of movement still further, so long as the block is kept in contact. Finally, the addition of a 6th point establishes the definite location we are seeking. Therefore, we see that it is necessary to have at least 6 locating points correctly arranged to definitely position a piece at a certain place. But sometimes a fewer number of stops can be employed successfully because some of these stops may combine several locating points in one member. For example, if we have a round hole in a piece of work, this can slide over a peg of the same diameter, which prevents the work from sliding to the left or right, or from front to back. If a shoulder is provided so the work can rest against it, it will locate the work from rocking. Therefore, the only remaining movement that it can make is to rotate. If the work is held against a second stop, it is located definitely in a single position. Round work is frequently located by means of a V-block, which combines 2 locating points in a single member. These V-blocks and one end stop provide us with suitable locating means for a cylindrical piece, which need not be restricted against rotation. V-blocks are suitable for locating members having rounded portions, and they are also convenient for clamping means, as in this case. Whenever we support a flat surface, it is preferable to use only 3 fixed points, and these should be spaced as far apart as possible. If we supply more supporting points than this, the additional points should be adjustable, and this is a good form of adjustable support. A spring in the base ensures contact between the plunger and the work, while the set screw clamps the plunger firmly in place. And regardless of the amount of pressure applied to the screw, the work is not distorted. The taper slide acts to resist any pressure against the support. The locating surfaces should be as small as possible, consistent with bearing area and wear, in order to make it easy to keep the fixture free of dirt and chips that would interfere with the proper seating of the part. If a locating pin is to fit within a hole in the part, it should be tapered to permit the work to be placed over it easily, and should be hardened and ground to size. A burr clearance should be provided around the pin. If flat surfaces are used at right angles, a dirt groove should be incorporated. In general, buttons are better supports and locating means than flat surfaces, and a button is better if it is placed end-on instead of sideways to the work. The work should be supported as nearly in line with the tool thrust as possible. In this case, the work is not adequately supported, and the thrust tends to bend the work. Another thing, the leverage of the extended work requires more clamping pressure to secure the piece. When the clamping jaws are more nearly in line with the thrust, the work is much better supported against the pressure applied by the tool. A fixture should always be designed so that the tool pressure comes against the solid part of the fixture and not against the movable or clamping portion. The part may be clamped in a variety of ways. Here is an example of a lever combined with a screw clamp. Sometimes a cam is used, and here is an interesting example. A wedge is another method of clamping. Whatever kind of clamp is used, the work must be correctly supported. This can be readily understood if we consider a board on 2 sawhorses. If pressure is applied in the middle, the board will bend. A good example of the proper clamping principle is an ordinary pair of pliers. To each other, the jaws can get a good grip on the work. Whereas, if we had a pair of pliers in which the jaws were not opposite to each other, they would obviously fail to work properly and would tend to bend the piece to which they were applied. Therefore, with this principle in mind, we can readily see the need for an adequate support directly under the clamping point. Drill jigs should be supplied with legs. Otherwise, chips would be more likely to interfere with the jig setting squarely on the table. Many authorities prefer using forelegs, so that if any dirt gets under one of them, it can be instantly detected because it permits the jig to run. It is important that these legs be made larger than the slots in the drill table, so that there is no danger of their dropping. The feet on a jig should be as far apart as possible, so that when pressure will not tip. One of the most important forms of jigs is the box jig, in which the top is hinged so that it may be opened to insert work and closed for the purpose of clamping. In this form, it must be kept in mind that the top must be accurately located if it contains any bushings, so that these will always come in the same place when the jig is closed. For this reason, it is better to have the ears rotate on the hinge pin, which is a drive fit in the center portion, as this provides better support. A still better method is to have the top fit closely between the sides, which provides the maximum possible support. In the case of drill jigs, bushings are used to guide the drill or other tool into the proper position. It may be pressed in permanently if only one size of drill is to be used. If several operations are to follow each other, such as a drill followed by a reamer, it is necessary to use slip bushings. These should be arranged so that they can be quickly changed, yet firmly held so that they do not work out during the operation of the tool. Here are several holding means for using these slip bushings. If a threaded bushing is used, it is advisable to locate the bushing by a smooth cylindrical surface, using the threaded section only for the purpose of holding the bushing in place. If the inner corner of the top of the drill bushings were left sharp, the drill would not enter easily. Therefore, these edges should be either rounded to a radius or beveled off. This chamfering should be the same angle as the point of the drill. There should be a space between the bottom of the drill bushing and the work to allow room for chip clearance. This space is usually approximately equal to the diameter of the hole being drilled. If the drill bushing is brought into contact with the work, the chips must pass out through the top of the bushing. This is occasionally permissible if the hole is a shallow one, which must be very accurately located. Another function that is frequently incorporated in both jigs and fixtures is the indexing of parts to produce a series of accurately spaced holes, slots, and so forth. Such fixtures range from the simplest hand-operated indexing disc and a pin like this, to automatic fixtures which are adapted to high-speed production of large quantities of parts. The part is held in the collet, which is tightened by a spanner wrench. After each slot is cut, a plunger on the right-hand side of the fixture strikes a stop, thereby indexing the part for the next operation. Removing the protective casing, we can see how this operates. A ratchet turns the mechanism, while a pin locks the mechanism while the cut is being taken. The reason for the existence of jigs and fixtures is the fact that they provide aid to the rapid production of duplicate parts. The amount of refinement and elaborateness of design of a jig or fixture naturally depends upon the number of parts and the saving in time it will effect. But in any case, it is important that the best parts work smoothly and accurately.